What is up, guys? It's your boy back again with another video. The lockdown's slowly getting to me and descending into madness, and my videos are getting more erratic. But I want to come at you today with a website called No Brain Too Small. This is a really good science website for New Zealand for NCEA. So type in No Brain Too Small and let's go to it. It looks like this. You got your physics, your chemistry, and your science, biology. Chemistry, we're doing level 2 chemistry, so let's go here. And you got all your internals and externals here. Our current external we're working on is called ASB, which is bonding structures and properties. And we're going to go down here to types of solids summary, because that's what we've been working on for the past week or so. And we have all our solids here. This is a really good summary sheet. I would recommend you printing these out and sticking them in your book when you get the chance. Let's go for a really quick overview of all the solids briefly. We start off with ionic solids. These are made of ions. The bonding is ionic. So ionic bonds, one electron from one atom is donated to another atom to become two ions, and they bond together with electrostatic attraction or ionic bonds. So they're made of positive and negative ions held together by electrostatic attraction in a 3D lattice. As these ionic bonds are strong, they require large amounts of energy to overcome their melting and boiling points, so large amount of energy in the form of heat to break the bonds. Solid ionic substances are made of 3D lattice, held together by tonic bonds. They're in fixed position and ions cannot move, so the solid will not conduct electricity. When melted or when dissolved in water, the ions become free to move, and this allows the liquid to conduct electricity. So as a solid, they cannot conduct electricity. When molten or dissolved, they can. The bonds within ionic solids are directional, so they're not malleable or ductile. They cannot be beaten into shape or pulled into a wire. Instead, they're brittle. If oppositely charged ions are forced to shift position, then charges are lined up and repel, causing the crystal to shatter. They're soluble in water, as the ions are separated from the lattice due to attraction towards the polar water molecules. Okay, next we looked at metallic bonding. Metals, they look like this. You got your copper cations. You got your metal cations with electrons flowing in between like a sea. So they're atoms, or you could say metal cations. The bonding in metallic is metallic bonding, or attraction to the delocalized sea of electrons. Many metals are hard and strong. They have high melting and boiling points, as there's a strong attraction to overcome between the valence electrons and the nuclei of neighboring atoms, or from the metal cations to the sea of valence electrons. The attraction of the metal atoms for the valence electrons are not in any particular direction. Therefore, metal atoms can move past one another without breaking the metallic bonds and without disrupting the structure, so they're both malleable and ductile. They can be beaten and pulled into wires. They're held in a 3D lattice by metallic bonding, which loosely held valence electrons attracted to neighbor ions, metal cations in a sea of delocalized electrons. You can just say this instead of trying to explain all this, which is why I've been saying this sentence over and over. The valence electrons are free to move throughout the structure in both the liquid and solid state. Because you've got electrons which are charged and they're moving, they can conduct electricity. And again, you know metals do not dissolve in water, because the metallic bonds are too strong to be broken by the attraction to the water. Next we looked at covalent networks. We have particles which are atoms, and these are covalently bonded to one another. We have this structure here, which is diamond. Diamond is made of carbon atoms. Each carbon atom is covalently bonded, which means they share electrons to 4 other carbon atoms in a tetrahedral arrangement. We'll learn more about tetrahedral arrangements next week, which form a covalent network solid. Covalent bonds between the carbon atoms are very strong and require a large amount of energy in the form of heat to break, meaning diamond has a high melting point. We looked at graphite, which is this, and these are sheets of graphene. Each sheet is graphene, the whole structure is graphite. Graphite consists of carbon atoms, each covalently bonded to 3 other carbon atoms in a trigonal planar shape. Again, we'll learn about this next week. In a 2D arrangement, so it's flat, forming layers with weak van der Waals forces between them. The weak attractions between the layers of atoms in graphite are easily broken, therefore it's soft and slippery, and the layers can slide off each other. In graphite, each carbon atom is bonded to 3 others, leaving 1 electron that's delocalized between the layers, and it's free to move around. So there's a free electron that's moving, meaning graphite can conduct electricity, diamonds cannot. Silicon dioxide consists of silicon and oxygen atoms held together by covalent bonds, so this is also a covalent network which cannot conduct electricity. The last thing we looked at was molecular solids, and these are particles which are molecules. They're made of molecules. There are weak intermolecular forces or van der Waals forces between the molecules, not in the molecules. These molecules are joined by covalent bonds, but between the molecules, like between this one and this one, you've got weak forces holding them together. So they require a small amount of energy to overcome. So molecular solids are the only solids with a low melting point. They're often liquids or gases at room temperature. Okay? They do not contain charged particles, no electrons or ions, so they do not conduct electricity as a liquid or a solid. Very important, there are strong covalent bonds between the atoms of the molecules, intramolecular forces, but these are not being broken when the solid melts or boils. They're just being, each molecule is separating from all the other molecules. Alright, have a look at this page. A reminder how to get to it. You're going to go on to No Brain Too Small under Chemistry, Level 2, ASB, and Types of Solids Summary. Alright, thanks guys for watching.